Hey, welcome to this lesson where we'll talk more on conditional statements. So what is a conditional statement? Should be a little bit of a review. A conditional statement consists of two parts, a hypothesis in the if clause and a conclusion in the then clause. For instance, if it rains, then they cancel school. It rains is the hypothesis. They cancel school is the conclusion. Essential questions of the lesson: what is a conjecture? What is a counterexample? And what can we find out more about conditional statements? By the end of the lesson, you should be able to understand the importance and necessity of geometric proofs. So we know what a conditional statement is, or an if-then statement. We're going to talk about related statements to conditional statements. So given an if-then statement, so for example, if P, then Q, we can create three related statements, and they are the converse, the inverse, and the contrapositive. We can start out first by talking about the converse. To form the converse of the conditional statement, we're going to interchange the hypothesis and the conclusion. So we're just going to flip them. We're going to switch them. So the converse of if it rains, then they cancel school is simply if they cancel school, then it rains. So instead of the hypothesis being it rains, it is now they cancel school. And vice versa for the conclusion. Instead of they cancel school, it is now it rains. Next, we'll talk about the inverse. To form the inverse of the conditional statement, we're going to take the negation. Okay, so that's kind of confusing, but it's the opposite of whatever the statement is, of both the hypothesis and the conclusion. So the converse of if it rains, then they cancel school is if it does not rain, then they do not cancel school. And lastly, the contrapositive, which is a mixture of both the inverse and the converse. We're going to interchange the hypothesis and conclusion, and we're also going to negate both of those parts of the statement. So to form the contrapositive of the conditional statement, we're going to interchange the hypothesis and the conclusion of the inverse. So the the contrapositive of if it rains, then they cancel school is if they do not cancel school, then it does not rain. Here's a great chart to help you remember the difference between the statement, the converse, the inverse, and the contrapositive. The statement is if P, then Q. The converse is if Q, then P. The inverse is if not P, then not Q. And the contrapositive is if not Q, then not P. I encourage you to pause this video right here and copy this chart down for your notes. Now we're going to talk a little bit about truth values. We're not going to get into much depth yet, but you have to know, at least viewing the last couple of examples, you should know that if it doesn't rain, or if it rains, that school might still happen. Or for example, if they don't cancel school, then it doesn't rain. That's not always true. So what we have to do is we have to evaluate both parts of an if-then statement. We have to evaluate the hypothesis and evaluate the conclusion. Whether or not both of those parts are true or false are going to tell us whether or not the whole statement, if P then Q, is true or false. We're going to start with using this table because it might help you more than if we put it into words. But if P is true, so if the hypothesis is true and the conclusion is true, then the whole statement is true. If the hypothesis is true, but the conclusion is false, then the whole statement is false. If the hypothesis is false and the conclusion is true, then the whole thing is true. And this is where it gets really tricky. If the hypothesis is false and the conclusion is false, you would think that the whole statement would be false. However, because you can't conclude that the statement is false, it has to be true. Don't worry, I'm going to take you through some examples, and here's our first one. Determine the truth value of the following statement for each set of conditions. If Sam rests for 10 days, his ankle will heal. Okay, so there's our if-then statement. That's what we're evaluating to be true or not. So Sam rests for 10 days, and he still has a hurt ankle. So the hypothesis is true, but the conclusion is false. Since the result is not what was expected, the conditional statement is false. So P was true, but Q was false. Therefore, the whole statement is false. On to our next example. Determine the truth value of the following statement for each set of conditions. So if Sam rests for 10 days, his ankle will heal. So Sam rests for 3 days, and he still has a hurt ankle. The hypothesis is false, and the conclusion is false. The statement does not say what happens if Sam only rests for 3 days, and his ankle could possibly still heal. So in this case, we cannot say that the statement is false, thus it has to be true. So this is the most confusing one, is when the hypothesis is false and the conclusion is false. We can't fully conclude that after 10 days his ankle will still hurt, because he's only rested for 3 days, not 10. So therefore, we can't conclude that if Sam rests for 10 days, his ankle will not heal. We can't conclude that that's what will happen. So we have to say that, because we don't know if it's false or not, we have to say that the statement is true. So if P is false and Q is false, then the whole statement is still true. Determine the truth value of the following statement for each set of conditions. If Sam rests for 10 days, his ankle will heal. Sam rests for 10 days, and he does not have a hurt ankle anymore. The hypothesis is true since Sam rested for 10 days, and the conclusion is true because he does not have a hurt ankle. So since what was stated is true, the conditional statement is true. So if P is true and Q is true, then the whole statement is true. And lastly, determine the truth value of the following statement for each set of conditions. If Sam rests for 10 days, his ankle will heal. Sam rests for 7 days, and he does not have a hurt ankle anymore. So the hypothesis is false, but the conclusion is true. The statement does not say what happens if Sam only rests for 7 days, but that's okay, we've got our result. So in this case, we cannot say that the statement is false, thus the statement is true. So if P is false and Q is true, the statement must be true. Here again is the table of truth values for conditional statements. If P is true or false, and if Q is true or false, and then what the outcome of the statement if P then Q would be, either true or false. So I encourage you to pause this video and copy this in your notes. Here we see our truth value table extended. Now we're not only just talking about the conditional statements. We're not only just talking about the conditional statements here. This was the table that you just saw on the previous slide. Now we're looking at whether the converse is true. Now we're in this column, we're looking to see whether the inverse is true. And in the last column, we're looking to see whether the contrapositive is true. So, any logical statement is going to be either true or false. So I encourage you, again, this is very important, copy this chart down into your notes. If you have any questions about it, we will talk about it during live class. And whenever you want to come into Math Cafe or call us or email us, we will help explain this chart to you. But I encourage you to copy this down in your notes. So, how do we decide if a statement is true or false? Well, what we're doing from the information given to us from the if-then statement is we're making what's called a conjecture. A conjecture is an opinion or conclusion formed on the basis of incomplete information. So if someone tells us a statement, we have to make a conjecture about whether it is true or not. If our conjecture will turn out to be false, it would be considered a counterexample. A counterexample is a way of proving that a statement is false. A great example of a counterexample that I could give you is if someone said that all rectangles are squares. Well, a counterexample would be that if I gave you a shape that had two sides that were 4 inches long and two other sides that were 8 inches long, I could say that yes is a rectangle. However, by definition, it is not a square. So that means the statement that all rectangles are squares is false. That's all for this lesson. Make sure you please come to live class. Try your assignments. Reach out if you need help. Come meet us in the Math Cafe or call us or email us.